Alright, so in this video I'm going to be solving the remaining part of the May-June 2018 paper 2 variant 2. So we have question number 6, which is a graphs of function question. Again, a very important topic for paper 2. So the first thing you do is that you plug in the value of -1. You have to complete the table in the first part, in fact. So you plug in -1, and in this equation, so let's see what you get. -1 squared is 1 divided by 2, 3 plus 2, so you get 5.5 positive. So let's write that down. So you're getting 1 mark for this, which I think are easy marks to score. And then you plug in 7, so 7 squared is 49, divided by 2, minus 3 into 7, plus 2. So you get 5.5 again. Alright, so you get 1 mark for this. And then you have to plot these points. So let's do that. At -1 you have 5.5, so let's mark that. At 0 you have 2, there you go. At 1 you have -0.5, so that's going to be between 0 and -1. And then at 2 you have -2, sorry about that. And then at 3 you have -2.5, so that's going to be between -2, in fact -2.5, so between -2 and -3. And then at 4 you have -2, so that shouldn't be too hard. And then at 5 you have -0.5, which is again going to be between 0 and -1. And then at 6 you have 2, and at 7 finally you have 5.5. Okay, so I'm going to join these points with the help of a smooth curve. Let's see, what do we get? So there you go. Okay, so make sure that it's a smooth curve and make sure not to miss out any point, and easy does it. Alright, so that's that. We have the curve drawn. We get 3 marks for this. So a lot of students complain that graphs of function is difficult, and yes, I agree it's difficult. I'm not saying that it's easy, but you can still easily scrape off at least 50% of the marks the question contains. So far you're going to get 1 mark for finding out the missing values and 3 marks for plotting the graph, and I think everyone can do that. Okay, and then you have to find the gradient at x equals to 1.5, so that means drawing a tangent. And when you're drawing a tangent, make sure that tangent is, as we know, theoretically tangent is a line that touches the curve at the point where it's supposed to. In this case it's 1.5, and it just, what's important is to make sure that it's not cutting the curve, right? That's what's important, to make sure that, in fact I think I need to fix my curve from here slightly, so let's do that. Yeah, much better. So let me redraw the tangent. So this at 1.5, so at 1.5 this is what the tangent will look like, and this takes a while since I'm drawing it digitally and not using an actual scale and a pencil. So there you go. Okay, and then in order to find the gradient, what I need to do is I need to pick 2 points on this tangent. So the points that you're going to pick, make sure that they're the points that you can read easily. So I'm going to take this point. This one looks good. In fact, let me switch to another color so that you can see clearly what I'm doing. So this point right here has coordinates -1, 2.2. Yeah, so it has -1 and 2.2. Let me write that down. And then let's pick another point. This point looks good. So this point has coordinates 3, comma, minus 3.8, 3.6, so minus 3.6. Okay, so I'm going to rewrite these 2 points, -1 comma 2.2, and then you have 3 comma minus 3.6. so let's find the gradient. The gradient of this line is going to be negative, so make sure that you have that at the back of your mind whenever you're solving this question, so that you know if in case you get a positive value, which could be due to a lot of reasons, could be due to sign error or just plugging them in incorrectly. So make sure that you realize that that's not what the answer is supposed to be. The answer is supposed to be negative. So the answer turns out to be -1.45, which is well inside our acceptable range. Alright, so that's part C. Let's do part D. Part D says complete these inequalities to describe the range of values of x where y is greater than or equal to 0. Okay, so y being greater than or equal to 0 basically means you're looking for the range of values of x where the curve is above the x-axis. Y is greater than or equal, if it were equal to 0, that means the point at which it's cutting the x-axis. Greater than 0 means the range of values of x from which x is the curve is in fact above the x-axis. So I'm going to highlight the 2 points at which the curve is cutting the x-axis. So if I stay on the right side of, what is this point? 5.2. Yeah, so if I stay on the right side of 5.2, all right, so I'm going to be safe because the curve is going to be above the x-axis. That means x is greater than 5.2, which again is well inside our acceptable range. So x is greater than 5.2, and then less than 0.987, 0.7, which also is inside our acceptable range. So there you go, you get 2 marks for this. On the same grade, draw the line 4y plus 3x equals to 12. Okay, so whenever you're making a straight line, it's always best to make y the subject. So 4y is equals to 12 minus 3x. And then if I make y the subject, so that's going to be 12 minus 3x upon 4. So ideally, I would prefer to write it like this, 12 upon 4 separately, which is 3, and then 3 upon 4x, so that I know exactly how to plug in the values. Let me show you what I mean. So basically, in order to draw a straight line, you need to have values, right? So the values can be positive, negative, or 0. So it's best to draw 3. Let me just, yeah. It's best to mark 3 points, but you don't absolutely have to do that. You can get away with 2 also. So I'm going to plug in 0, and when I do that, y turns out to be 3, and I'm going to plug in 4. Now the reason behind doing that is because 4 is a multiple of 4. So if I plug in 4 here, 3 into 4 is 12, 12 upon 4 is 3, and 3 minus 3 turns out to be 0. So the whole idea is to get integer values. Okay, so 0, 3, and 4 comma 0. 0, 3, again let me do this with a different color. I'm going to go with purple. 0, 3, and 4, 0. So let's join these 2 points with the help of a straight line. So there you go. Okay, so this looks good. Let's see what we have to do next. So what we have to do next is the x coordinates of the points of intersection of this line and the curve are solutions of the equation. Okay, so basically this is a standard trend whenever you're solving questions related to graphs of function, that towards the end it's going to give you an equation. It's going to tell you that this equation, you know what, is a solution of this line and this curve. Okay, so find the value of a and b. So the reason why this equation is the solution is because this contains both. This contains the equation of the curve and the equation of the straight line. So, and this would have been achieved by solving the 2 equations simultaneously. So that's exactly what I'm going to do. I'm going to solve the 2 equations simultaneously. What 2 equations? These 2 equations. And y is equals to, let's go back to the equation of the curve, x squared upon 2 minus 3x plus 2. X squared upon 2 minus 3x plus 2. Now this requires, questions like these are very algebra intensive. Okay, so you need to know how to cross multiply, LCM, stuff like that. So x squared upon 2 minus 3x plus 2. So straight away I'm going to go with LCM. I'm going to take the LCM on the right hand side. Alright, so the LCM is going to be 2. That's a no-brainer. X squared minus 6x plus 4. Right, and over here we have 12 minus 3x upon 4. Now at this point it's best that you cross multiply, but if you simplify before that, it's going to save you a lot of time. So whenever you have an equals to between, you simplify the denominator with the denominator and the numerator with the numerator. So now I can cross multiply. So 12 minus 3x is equals to 2x squared minus 12x plus 8. So let's shift everything on the right hand side. So this is 0. 2x squared minus 12x plus 3x plus 8 minus 12. So 2x squared minus 9x plus 8 minus 12 is minus 4. So let's write this nicely, and when I say nicely, I mean like this, right? So 2x squared, according to the question, the equation that we should have ended up with is 2x squared plus ax plus b. So we can see that a is equals to minus 9 and b is equals to minus 4. Let's see if that's the correct answer. Yep, it is minus 9 and minus 4. So far so good. Alright, let's do question number 7. Further trigonometry. Again, very important concept, topic in fact, for paper 2. Show that CAB is 62.2. So CAB is this angle, correct to 1 decimal place. So we can have a straight head-on approach with questions like these. We're going to use sine rule to get CAB. So sine CAB divided by 3.7 is equals to sine 42 over 2.8. Cross multiply, take the sine inverse. So sine 42, this is what I'm doing in my calculator. Sine 42 divided by 2.8 into 3.7, and then I'm going to take the sine inverse of the answer. So I end up with CAB is equals to 62.2, correct to 1 decimal place. 3 marks in the bag. Calculate, find the bearing of A from C. So this is a 2-mark question. A from C. So now that we have 62.2, now if you have seen the videos in which I've taught bearing, there's a concept that I've taught which is called reverse bearing. If you haven't, I'd suggest that you go check it out. So in reverse bearing, what we do is, now here the question is asking for the bearing of A from C, which theoretically means that the question is asking for this value. This value. Okay, now we can work this out, it's no harm, all right, but an easier way to solve this would be to first work out the bearing of C from A, because we have everything we need in order to do that. C from A basically means that we're going to start from the north of A and we're going to keep on going till we touch the line that's joining A and C. So this is going to be 135 plus 62.2, which is equal to 197.2. 197.2. Now the concept of reverse bearing says is that if you have the bearing of A from B and you want B from A, so you either add 180 or you subtract 180. When do you add? You add when the opposite bearing is less than 180, and when do you subtract? You subtract when the opposite bearing is more than 180, which it is in this case. So in this case, since it's more than 180, I'm going to subtract 180 from this in order to get the bearing of A from C, and that turns out to be 17.2, which I'm going to write as 017.2 degrees. So there you go. You get your 2 marks for that. Okay, then it says the yacht sails from A to B to C to A. Okay, so basically it's going from A to B, B to C to A. So technically it's just asking for the perimeter of this triangle. So what I need to do first is, if I want to find out the perimeter, so I have the 2 lengths, but the third length is missing, so AB is missing. So let's see what we can do in order to find out AB. So we can work out this angle, right? So we have 62.2, correct to 1 decimal place, plus 42, 180 minus answer. So I get what? I get 75.8. 75.8 degrees. So I have 2 sides and an included angle now, which means I can use cosine rule. So I'm going to do this over here. AB is, this I'm sure would be a 4-mark question, yeah. So AB is equals to the square root of 2.8 squared, 2.8 squared plus 3.7 squared minus 2 into 2.8 into 3.7 into cos, what was the angle again? 75.8. Okay, so let's work this out. 2.8 squared plus 3.7 squared minus 2 into 2.8 into 3.7 into cos 75.8, and then I take the square root of the answer, so this turns out to be 4.05, which I'm going to have to lock at 4.06. Alright, so far so good. What we have to do next is that we just have to sum all the lengths up, which means 2.8 plus 3.7 plus our newly worked out length. So here's what I'm doing. 4.06 plus 2.8 plus 3.7. So let's see, what do we get? So we get 10.6 kilometers. So we don't have to worry about kilometers. 10.6, however, is our final answer. So far so good. Let's do question number 8, similar triangles and vectors. This, by the way, was quite a difficult vectors question, I would say. I haven't seen a question that's so tricky. I'm not sure if I should say difficult, but yeah, tricky to understand at first. I haven't seen a question like this in a very long time. So it says prove that triangle ABX is similar to triangle COX. Alright, so let's focus on, in fact, there's a lot of things that I didn't read. OYC is a triangle, alright, I can see that. A is a point on OY and B is a point on CY, fantastic. AB is parallel to OC, alright, thank you. AC and OB intersect at X, alright, I can see that also. Prove that triangle ABX is similar to COX. So ABX and COX, let me highlight the 2 triangles for you. So ABX and we have COX. Okay, so we have to prove that these 2 triangles are similar. So because of the fact that AB and OC are parallel, we can state a lot of things. We can say that these 2 angles are going to be the same. Reason for that is because that alternating angles. So BAX is basically equal to angle OCXY, alternating angle. So make sure that you write, as the question says, that give a reason for each statement you make. So make sure that you do that, alternating angles. And then this angle right here is going to be equal to this angle. So you're going to say angle ABX is equal to angle XOC. Reason is the same, alternating angles. And then finally, these two angles are also going to be the same. Reason, however, is not alternating angles in this case. In fact, it is what do you call vertically opposite. Sorry, my bad. So in this case, you're going to say AXB is equal to angle OXC because of vertically opposite. Excuse my handwriting, please. Okay. So yeah, 3 marks for that. Okay, so this is where things get slightly tricky because now we have vectors and similar triangles also. So it says find as simply as possible. In fact, before that, it says OA is equals to 3A, OC is equals to 6C, CB and BY are in the ratio 1:2. Find as simply as possible in terms of A and or C, AB. Okay, so let's go back. OA is 3A, right? So let's write that down, 3A. OC is 6C, let's write that down, 6C. And then CB and BY are in the ratio 1:2. Okay, so there are a lot of things that we can work out just through this, okay? The fact that CB and BY are in the ratio 1:2 means that OA, sorry about that, and AY will also be in the ratio 1:2, which means that AY will also be 6A. Okay, what else can we work out? Okay, now there's something else, and this is where a lot of students can go wrong, okay? So it's not just the two triangles that we found that the question asked us to prove are similar. There is another pair of similar triangles, okay? And which one is that? Let me show you. So you have triangle AYB, which is similar to triangle OYC. And the reason is not alternating angles, it's because of corresponding angles, right? Let me just quickly show you why they're similar in fact. So this angle is going to be equal to this angle because of corresponding angles. Remember, AB and OC are parallel. This angle is going to be equal to this angle for the very same reason, and they share an angle which is angle Y. Okay, now with having said that, now what we can do is we can work out what AB is, because that's, I think, what we have to eventually, yeah. So here's how this works. Pay close attention. AB and OC, since they're corresponding lengths, are going to be in the ratio 2:3. Okay, why is that? Because YB is 2 parts and BC, which is 1 part, means that YC will be 3 parts. So that means these two triangles that I just mentioned are similar, but they're similar in the ratio 2:3. So now the question was kind enough to give us OC, which was 6C. We can work out AB, and AB is going to be equal to what? 3 1s are, 3 2s are, 2 into 2 is 4C. So now that we have worked out AB, let me just copy and paste it here so that you know where it is where it's supposed to be. In fact, let me just drag this over here. Yeah. Okay, so now we have AB. So this is the tricky part, that because the question is asking you to prove a different pair of similar triangles, while we know that, in fact, and later on we realize that there is another pair of similar triangles. So that's why I thought that this question was slightly tricky. Anyway, once that's done, it gets easier. Then you have to find CY. So if you want to find out CY, your safest bet is to go from C to O, and then from O to Y. So CO is going to be minus 6C because we're going in the opposite direction. So minus 6C plus 3A and 6A, so that's 9A. Let's check the answer. 9A minus 6C, that's fine. Same thing. Okay, then it says find in its simplest form the ratio OX is to XB. Alright, so let's have a look at OX, and let's see where's OX. Okay, OX and XB. Alright, so considering that we worked out what AB is for C, so OX and XB are corresponding lengths. In fact, let me just clear this mess that I've made here to give you guys a better picture. Okay, so we know very well the triangle ABX and COX are similar. Alright, so we don't necessarily need to know the ratio of OX is to XB. What we can do is we can find out the ratio of another pair of similar or corresponding lengths. So that's exactly what I'm going to do. I'm going to go with 6C and 4C because all the lengths are going to be in the same ratio. So I'm going to do 6C is to 4C, so the 2 C's get cancelled out, and this becomes 3:2. 3:2. And then it's talking about the ratio of the areas of the same triangles. However, there is a catch. Is there a catch or is there not a catch? No, there is no catch. Okay, so what I'm going to do is A1 upon A2 is equals to L1, which is 3 upon L2, the whole thing square. So we get 9:4. Alright, easy does it. So far so good. Okay, then we have part 3, which says area of triangle AYB. Okay, AYB, where are you? Okay, there you are. Is to the trapezium, let me check, OABC. Okay, so for this, what I'd like to do is, I'd like to draw this separately. Okay, so I'm not going to take much time. Okay, there you go. And there you go. Okay, so we just figured that these two triangles are similar in the ratio 2 is to 3. Is that what you figured? Yeah, 2 is to 3. Okay, so that basically means that if this length right here is 2 parts, this entire length is 3 parts. So what we can do is we can figure out the ratio of the areas. So a1 upon a2 is equals to 2 upon 3, the whole thing squared, which is equal to 4.9. Now one thing I should mention is that I cannot use the similar the a1 upon a2 formula with a triangle and a trapezium. Why? Because as I always say, that formula can only be applied to two similar shapes, and a triangle cannot be similar to a trapezium, just like how an apple cannot be similar to an orange. Okay, so we got to compare apples with apples and oranges with oranges. So 4 is to 9. Now this basically means that if the area of this little triangle is 4, area of the entire triangle is 9, which means that if I want to work out the area of trapezium, I can simply do 9 minus 4, which is equal to 5. So there you go. 4 is to 5 is your final answer. Alright, so that was question number 8. Okay, now we're doing question number 9, which is the second to last question. Okay, so it says on Monday, Ravi goes on a 20-kilometer run. His average speed for the first 12 kilometers is x kilometers per hour. Write down an expression in terms of x for the time taken for the first 12 kilometers. Alright, so time, as we know, is equals to distance upon speed. So the distance is 12, the speed is x, so 12 upon x, but there's a catch. The question wants us to give the answer in minutes, so we're going to do 12 into 60, which is 720 upon x, so don't need a calculator for that. 720 upon x is our answer to part 1, which is correct. Then it says his average speed for the final 8 kilometers is 1.5 kilometers per hour slower than for the first 12 kilometers. So what was his speed for the first 12 kilometers? It was x. Being 1.5 kilometers per hour slower than x basically means x minus 1.5. So speed here is basically x minus 1.5. The distance is 8. Time is equals to distance upon speed. So time is equals to 8 over x minus 1.5. And again, this also the question wants in minutes. So we're going to do that. 8 into 60 is 480. So 480 upon x minus 1.5. So far so good. Okay, then it says Ravi takes 112 minutes to complete the full 20-kilometer run. Okay, so 110 minutes to complete the full 20-kilometer run basically means that the sum of the two times that we just worked out. So 480 upon x minus 1.5 plus 720 upon x is equals to 110. Okay, why are we taking 110 as it is? That's because the time that we worked out was in minutes, and this 110 is also in minutes. Okay, so now it's a matter of taking out the LCM, cross multiplying, and getting to the final answer. So the LCM is going to be x squared minus 1.5x, right? We just multiplied the two together, and then we're going to have 480x plus 720x minus, let's see what 720 into 1.5 is, 1080 is equals to 110x squared minus, let's see what 1.5 into 110 is, that's 165 with an x. Okay, in fact I think I skipped a step, I shouldn't have done that. Alright, so I'm just going to leave this as it is, equals to 110. I'll do that in the next step. Okay, so 480 plus 720, let's see what's that equal to. 480 plus 720 is equals to 1200. So 1200x minus 1080 is equal to 110x squared minus, what was this again, 110 into 1.5, 165 x 110x squared. Alright, so now it's just a matter of rearranging everything that we have. So 110x squared minus 165x minus 1200x plus 1080 equals to 0. In fact, I'm going to put an equals to sign after. So yeah, let me just drag this to the right. Okay, so now we have to first simplify this, and then we'll decide what to take common. So this is going to be 1365x plus 1080 equals to 0. So if you look at the equation, here we have 22 and here we have 110. So what's 110 divided by 22? It's 5, so that means we have to factor out 5. So I'm going to take 5 common. If I do that, 110 divided by 5 is equals to 22x squared. So far so good. 1365 divided by 5 is 273. So far so good. And 1080 divided by 5 is 216. That's exactly what we wanted. Equals to 0. So now this simply reduces to 22x squared minus 273x plus 216 equals to 0, and we get all the marks we're supposed to by showing that this is what it equals to. Okay, so now we have to solve this equation. So to save some time, I'm going to use my calculator. All right, the formula that we're going to use is a quadratic formula. So again, a lot of students tend to complain, a lot of students complain that quadratic equations is also a difficult topic, but again, this questions like these you can always get right given that you know the quadratic formula. So now whenever I say things like that, I'm talking about the bare minimum. Okay, I'm not encouraging students to forget everything else and just focus on this. I'm saying that even suppose, God forbid, you're not able to solve the parts above, you can still scrape off more than 50% of the marks from the given question, even from the most difficult topics. So when you solve this, a, by the way, is equals to 22, b is equals to minus 273, and c is equals to 216. So what you get is, you're supposed to give your answer correct to 2 decimal places. Make sure that you read that. 11.56 and 0.85, which is the correct answer. Okay, then it says, on Friday, Ravi ran the whole 20 kilometer at the same average speed that he ran the final 8 kilometers on Monday. Now, what was his speed when he was running the final 8 kilometers? His speed was x minus 1.5. Now, at this point, we have to decide what value of x to take. So I can't take 0.85 because it's less than 1.5, because ultimately I'll have to subtract 1.5 from it. So that means I'll have to take 11.56. So that's exactly what I'm going to do. I'm going to take 11.56 minus 1.5, which tells me that his speed on Friday was basically equal to 10.06. Then it says calculate the time Ravi took to run 20 kilometers on Friday. So time, as we know, is equal to distance upon speed. So 20 divided by 10.06. Let's find out, and then multiply it by 60. So I get 119 minutes. So that means which is basically equal to 1 hour, and let's subtract 60 from this. So I get 59.28, since I have to give it correct to the nearest minute. So I'll lock this at 59, which is the correct answer. Okay, so that was that. Now we're at the last question, which is again sort of like vectors, sort of like coordinate geometry. So A is the point, and we have B. So the first thing I have to do is find the midpoint. That's a no-brainer. So I'm simply gonna sum up the x coordinates. So when I do that, so when I sum up the x coordinates, I get minus 4 plus 2 upon 2, and then minus 1 plus 2 upon 2. So minus 4 plus 2 is minus 2. Minus 2 upon 2 is minus 1. So that means the x coordinate of the turning point is minus 1. And minus 1 plus 2 is positive 1. 1 divided by 2 is 0.5. So it's up to you. If you want to write your answer in decimal, you can. Or if you want to write it in fraction also, you can do that. Okay, so far so good. And since this is a point, let me make a bracket, although that really makes no difference. Next, you have to find out the gradient. Again, this is a very easy question. You're just getting 1 mark for remembering the formula of the gradient. So gradient, as you know, is y2 minus y1 over x2 minus x1. So y2 basically means 2 minus minus 1, 2 minus minus 1 over 2 minus minus 4. So that's 3 upon 6, which is equal to 1 upon 2. Again, you have a choice whether you want to write your answer in decimal or fraction. Show that BC is perpendicular to AB. Okay, so when you have BC in vector form and you want to work out its gradient, it's very simple. All you got to do is you got to take the y component divided by the x component. So if I want to find out the gradient of BC, that's going to be equal to minus 8 upon 4. So that means the gradient of BC is equals to minus 2. Now, I already have the gradient of AB. So what happens when you multiply gradients of two perpendicular lines together? You get minus 1. So this is all you have to do. Hence, shown. Right? If, however, they weren't perpendicular, then the answer would not have been minus 1. Okay, now we are at part D, which says ABCD is a rectangle. Find the coordinates of the point D. So ABCD being a rectangle basically means that BC is going to be the same as ABCD. DC, yeah, let me show you what I mean. Since ABCD is a rectangle, that means I think I said AB is equals to DC. Anyway, that's not what I meant. Right, let me show you what I mean. So here's A, here's B, here's C, here's D. So ABC is going to be the same as AD, alright? So now here's how this works. So BC is 4 minus 8, right? So BC is 4 minus 8, so that means AD will also be 4 and minus 8, okay? So here's how this works. So the coordinates of A are minus 4 and minus 1. Alright, so AD being 4 minus 8 basically means that you're going 4 units towards the right because it's positive, and minus 8 basically means that you're going 8 unit downwards, okay? So what happens when you're at minus 4 and you move 4 units towards the right? You get 0. And what happens when you're at minus 1 and you move 8 unit downwards? What do you get? You get minus 9, because minus 1 minus 8 is minus 9. However, if you want, you can work it like this also. AD is equals to OD minus OA. Alright, OD you can leave as XY, and OA you can write as minus 4 minus 1, and set this equal to AD, which as we know is the same as BC. Okay, and then you can work this out and get your answer, which again is going to be minus 9. Then it's asking you to calculate the perimeter. Now perimeter basically means sum of all sides, so we just have to work out two sides, alright? So I can work out AB. In fact, I should work out AB. I have the coordinates of B and they are 2, 2. Is that correct? Let me double check. Yep, that's correct. Okay. So AB, let me just do this over here. So AB is going to be equal to square root of 2 minus minus 4, the whole thing square. So I'll just write it as 6, okay, plus 2 minus minus 1, so that's 3 squared. So AB is equals to 36 plus 9, that's 45. So let's just keep it as root 45 for now. And then BC, okay, so if I want to work out the length BC, by the way, I should make a magnitude sign here. So all I got to do is I got to take the vector BC and square it and sum it up. So this is going to be equal to square root of 4 square plus minus 8 square. So this is going to be equal to 16 plus 64, which I believe is 70, 80. Yeah. So here's what I need to do. 2 times root 45 plus root 80. So let's see what do we get to find the perimeter. Root 45 plus root 80 times 2, so you get 31.3, which is the correct answer. So the perimeter is equals to 31.3 units. 31.3. Alright, so with this we are finally, thankfully, alhamdulillah, done with the paper. And I hope you guys understood. Let me know if there's a question that you did not understand, and I'll try and be more regular with these past papers so that you guys can keep preparing for your July-August series or even for October-November. So that's all for this video. Make sure that you have subscribed to my channel in case you haven't, and do follow me on Instagram because I post a lot of useful content there. So yeah, that's all for this video. See you guys in the next one. Until then, take care. Bye-bye.